Dear viewers, welcome back to the TCE LearnEasy program. In this lecture, we'll be learning some fundamentals of strength of materials. In the subsequent lectures, we'll be learning fundamentals of all civil engineering subjects. So, to start with, let us begin with stress. So, we very well know that stress is given by load divided by area of cross section. Load divided by area of cross section. The notations will be stress, we can use small p or sigma equal to load capital P divided by area of cross section or the resisting area. Load divided by resisting area will be the stress. So the units for stress will be, since it is force divided by area, force shall be taken as Newton, area shall be taken as millimeter squared. So Newton per millimeter squared will be the units for stress. And strain, epsilon or small e equal to change in length by original length, delta L by L. Then Hooke's law. So we know that when a material is loaded within its elastic limit, stress will be directly proportional to strain, or stress by strain equal to some constant. So stress is small p, strain is small e equal to constant. That constant is the Young's modulus or modulus of elasticity, capital E. So if you want to find capital E, stress divided by strain, stress is load by area, strain is delta L by L. So it will result in with PL by A delta L. So Young's modulus equal to PL by A delta L, where P is the load, L is the length, A area of cross section, and delta is the change in length. So if you want to find Young's modulus, we can use this relationship, or if you want to find the change in length, you can use PL by AE. So using these relationships, some numerical examples shall be asked in the objective type questions. Say may be given load and diameter of a bar, maybe the stress values, 4 values will be given. So you need to calculate load divided by cross sectional area. So if it's a circle, pi d squared by 4. If it's a rectangle, b into d. If it is a triangle, half bh. Like as we have a formula for different cross sections. So load divided by area will be stress. So, or you may be asked to find strain, may be given the change in length and original length. So, you need to have these two in same units, and the strain will not have any unit because delta L by L, so it will not have any unit. Whereas Young's modulus E equal to PL by A delta L, P is Newton, L is millimeter, Newton millimeter divided by millimeter squared. This is millimeter, millimeter cube. So, we'll be getting Newton per millimeter squared will be the units for Young's modulus, Newton per millimeter squared. And if you want to find delta L, change in length, that will be PL by AE. The unit for delta L, that is change in length, will be load is N Newton, L millimeter. So Newton millimeter divided by millimeter squared into Newton per millimeter squared, because Young's modulus unit is Newton per millimeter squared. So we'll be getting delta L, the unit for delta L will be millimeters. So we need to be very strong in units. Even if we forget the units, you should be in a position to derive from the basic relationship. Then, if you want to find the deformation of a body due to its own weight, then it is given by WL squared by 2E, where W is the specific weight of the material. Every material will have its own specific weight. For example, steel will have 78.5 kilonewton per meter cube. Concrete, if it is plain, 24 kilonewton per meter cube. If it is RCC, 25 kilonewton per meter cube. So that specific weight multiplied by L squared by 2E will give you the deformation of a body due to its own weight or self weight. And in case if we have a tapering body, say if the cross section is tapering, then we can use this relationship to find the deformation of a uniformly tapering body. That is 4 PL by pi into Young's modulus into D1 D2, where D1 will be diameter at one end and D2 will be diameter at the other end. Similarly, the concept used for finding stresses in composite bars. So if you have composite bar, that is, if it is made up of more than one material, then this basic principle will be used. That is, strain in one material should be equal to strain in other material. That is the basic principle in composite bars. So strain in one material equal to strain in other material. So if you want to find strain, we know that stress divided by Young's modulus. So P1 by E1 equal to P2 by E2. So using this, we can find relationship between P1 in terms of P2 or P2 in terms of P1. Then another principle in case of composite bars is the total load carried should be equal to load carried by one material plus load carried by other material. That is, both the materials have to combine, they will jointly resist the applied load. So total load carried should be equal to load carried by one material plus load carried by other material. So if this is capital P, the load, we know that stress into area will be loads P1 A1 plus P2 A2. So using these two relationships, you can solve problems of composite sections. Then if you are interested in finding thermal stress, say if you want to find thermal stress, the thermal stress small p is given by alpha TE, where alpha is the coefficient of thermal expansion, T is the temperature, and E Young's modulus. So change in length due to change in temperature equal to L alpha T. So L alpha T will give the change in length due to change in temperature. Stress, if you want to find alpha TE, and then change in length L alpha T. Then we should know about various elastic constants. So first elastic constant, Poisson's ratio. Poisson's ratio is lateral strain by linear strain. So lateral strain will be change in lateral dimension to original lateral dimension, and linear strain will be change in linear dimension to original linear dimension. Similarly, if you want to find volumetric strain, there will be change in volume by original volume. Modulus of rigidity is given by shear stress by shear strain. Then we have relationship between Young's modulus and rigidity modulus and Poisson's ratio. That will be equal to E into T 2C into 1 plus 1 by mu. Actually, if you divide by m, m by m will be 1 plus 1 by m. So 1 plus mu. So E equal to 2C into 1 plus mu, where mu is the Poisson's ratio. Or E equal to 3K to 1 minus 2 by m, where K is the bulk modulus and 1 by m is Poisson's ratio. So E equal to 3K into 1 minus 2 by m, that is one relationship. And E equal to 2C into 1 plus 1 by m, that is the relationship obtained here. Thank you, viewers, for patiently listening. We will have a series of lectures covering the civil engineering fundamentals. Thank you for subscribing our channel and keep sharing this information among your friends.